Hello and welcome to Minter Dialogue, episode number 502. My name is Minter Dial and I'm your host for this podcast, a proud member of the Evergreen Podcast Network. For more information or to check out other shows on the network, please go and visit evergreenpodcasts.com. I'd like to give a quick shout out and thanks for putting up a 5-star review by DTLD from the United States. Thank you very much. So this week's interview is with Dr. Michael Hauser. Dr. Hauser is an Emeritus Astronomer. In his capacity as Deputy Director of the Space Telescope Science Institute, Mike was instrumental in transforming the Institute into a multi-observatory organization that included the work on the Hubble and James Webb Space Telescope programs. Mike was a member of the COBE science team and was part of the Nobel Prize delegation in Stockholm in 2006. And the Nobel Prize in Physics was awarded to John Mather and George Smoot for their discoveries using NASA's COBE satellite. In this conversation with Mike, we discuss his career highlights, some of the key discoveries he was part of, the challenges and benefits of international collaborations in light of geopolitics, the value of theory versus observation, the future of space exploration, and the nature of ambition in space. You'll find all the show notes on minterdial.com. And please, if you have a moment, do drop in a rating and review, and don't forget to subscribe to catch all the future episodes. Now for the show. Mike Hauser. Hello.
Good morning, Minter.
It's great to have you on the show. I'm really delighted to be able to chat with you. So just for people who are listening, to start off with, tell me, where are you calling in from, Mike?
I'm calling from my retirement home in Baltimore, Maryland.
A place I know well, because my father is there too. So, Mike, in your own words, how would you like to describe yourself?
I'm a much retired astrophysicist. I'm a physicist by training. In fact, my early career was in nuclear physics, particle physics, high energy physics, working on accelerators to explore the structure of matter. But I became interested in astrophysics and involved largely because I was invited to form a new research group in infrared astronomy in space by a senior scientist at Goddard Space Flight Center, whom I knew well. And he had confidence that if I were to form such a group, it would be successful. And indeed it was. In our early years, we proposed 2 spaceflight experiments, one of which became the infrared astronomical satellite, jointly with the Dutch, that did the first survey of the whole sky at far infrared wavelengths. And the second, proposed at the same time, was called the Cosmic Background Explorer, which was to make precision measurements of the cosmic microwave background radiation, which had been previously discovered and was proof that the Big Bang really occurred. That was the remnant radiation predicted for the universe if there had been a Big Bang. And so our Cosmic Background Explorer satellite was designed to make more precise measurements of that radiation. And it was successful as well. 2 members of that team actually received Nobel Prizes for the quality of the measurements that we made. I was just a member.
I wanted to ask you, Mike, just to circle back at the very beginning, what actually got you started on this journey of astrophysics? You were talking about how you were brought into the specialization and the output and figuring out how to find these remnants of the Big Bang. But what was early Mike? What got him started on astrophysics? Was it looking up at the stars and saying,
Well, it's interesting. As I said, I started out doing research on high energy physics, and I was trained in math and physics. And although the Sputnik satellite was launched in the first few months of my undergraduate career at Cornell, I had no immediate interest in getting involved in that. And so that didn't happen until many years later. I was working in high energy physics, but largely as a postdoc, and I was interested in a little more secure employment.
As one does.
I had a family, wife and 2 kids. Mm-hmm. And so when the invitation came from a senior scientist at Goddard Space Flight Center who knew me and said, wouldn't I like to start an infrared astrophysics program in space? I responded with great enthusiasm, and they hired me.
So that's where you pivoted into the astrophysics part of it. I get it.
Exactly. Mm-hmm.
So if you look back at your career, Mike, illustrious as it is, was there one thing that stands out as the highlight of your career, a moment that you can remember, or a thing that you achieved?
Well, there are some. Of course, the award of the Nobel Prize to my teammates on the Cosmic Background Explorer satellite, acronym COBE, was a great thrill. Our team actually received a prestigious prize earlier that same year. That was in 2006. What was called the Gruber Family Foundation Prize in Cosmology. And that was awarded to the whole team. So I felt quite good about that. And of course, even more so when a few months later, the Nobel Prizes were announced and 2 of my colleagues were singled out as Nobel laureates, which led to a wonderful week in Stockholm. We all went there to watch them receiving the prize, and that was extremely exciting.
Yeah, I've never really, I've talked to a few Nobel laureates, but I've never asked what it's like to be in the room, in the moment, the solemnity of the joy of receiving such a prize.
Right. Well, we witnessed all of that. We were invited, my wife and I, Deanna, and I went to Stockholm. We acquired the necessary formal attire to attend the formal events of awarding of the prize. The King of Sweden presents the prize to the laureates. And so we were sitting in the audience, bird's eye view of all of that. And that was very exciting.
I can well imagine. So I was just listening to you, Mike, and thinking about how when you look at a photograph of the space, photographs taken by Hubble or James Webb or whatever, I wonder how you look at them differently than I do, because I look at them and I look at them maybe from an aesthetic standpoint. I recognize I'm just a layman. I'm guessing that you almost can pick out what's happening. Certainly you know how difficult it was to achieve it. How does that change the way you view these photographs versus someone like me, a complete, non-astrophysicist?
Well, I can interpret based on my experiences what I'm seeing, but it is still remarkable that we can see very distant galaxies. The Hubble telescope has seen the most distant star yet recorded. And Hubble is still remarkably working well. I remember the challenges of getting Hubble to work because of the flaw in the shape of the mirror, and the challenges of servicing Hubble. I was involved with. I was on the science management team for each of the servicing missions that had to plan and then practice many times before any given servicing mission. But anyway, when I look at the sky as imaged by Hubble, and that's in the ultraviolet and visible light, it's very familiar. I understand what we're seeing. But when I look at the sky as seen by the James Webb Space Telescope, which we now have working spectacularly well for us, I had a hand in promoting the development of a large telescope capable of far infrared observations, which instead of seeing the starlight directly, they see the heated gas and dust in galaxies produced by the starlight. And so it's an entirely different view of the universe. And to me, it's very exciting because I've been working in the infrared for many years.
And presumably it's a little fulfilling too, to know that you've contributed to these instruments and to what they're able to bring back to us in terms of photographs.
Right. There are many advisory processes that go on before deciding what to do in space. And I've been on numerous such committees. One in particular was called the HST, Hubble Space Telescope and Beyond, which was one of the first to say, okay, Hubble's in the plan. What are we going to do next? And in that committee, of which I was a member, there was a recommendation for a fairly large aperture far infrared telescope, which in fact Webb has exceeded what we suggested at the time, but sort of marginally larger. So I feel very good about having had a hand in all that.
I can bet. And you were mentioning just before about with Hubble, the size of the mirror. As I've read, we're talking about minute differences, as I understand it, and the level of detail that you must go down to. So first of all, correct me if I'm wrong about what type of millimeter, or whatever it is, size differences that we're talking about. 'Cause obviously, we're talking about very large mirrors, and everything has to be down to such a ridiculously small detail.
Well, the Hubble primary mirror was a spectacular embarrassment because the outer edge of it was not machined to the right dimension. And as a result, the images initially were fuzzy. And there had been huge expectations of Hubble, finally a major telescope in space, unimpeded by atmospheric interference. And the direct images were fuzzy and couldn't be focused. It probably escaped much of the public's attention that Hubble was still working initially perfectly well with its spectrometer, which didn't need such a sharp image to collect and analyze the spectrum of objects that it was looking for. So science program went on, but a major engineering analysis of what the problem was, and when they analyzed the shape of the images, they recognized that it was a simple optical defect called spherical aberration that accounted for the fuzziness of the images. And so then some very brilliant engineering was done to invent a way to add an additional optical element between the mirror and each instrument that would correct that optical aberration. And the mechanical design to put, they needed such a special corrective mirror for each of the instruments on Hubble. And an engineer involved was at a trip to England. And in taking a shower, he noticed that the shower had a sliding holder for the spray, and thought, aha, I can build a replacement instrument for Hubble with a sliding bar and put an optical correction mirror for each of the instruments on there, and then deploy those individual arms. And that's the first fix that was done for Hubble, called the corrective optics for space telescope axial replacements.
Well, in the layman's term, I might call it another eureka, not in a bath, but in a shower.
In a shower, and definitely it was, and that's a good description of it.
So I personally, my career has always been in business, and the idea sometimes of success within a business can be marred by internal politics. In space exploration, we've got a lot of external politics, but we also have internal politics. Within your cohorts, people have career plans. Then you have the international components of it, where politics and budgets from governments, and then you have the technical aspects of actually putting the materials together to do what you're trying to achieve. When you look at what you've worked on, Mike, which of those are the hardest, or is it always all of them that are hard?
I guess every step has its hard challenges. The major space programs are generally done collaboratively between nations, and there are national interests that sometimes conflict. A simple early example, in fact, was on the very first infrared astronomy mission that I worked on, called the Infrared Astronomical Survey. That was satellite, or IRAS, was a joint mission between the Netherlands and the US at a very early time in the space program. This was a small scale, by later standards, mission. The Dutch had flown one of their own in ultraviolet and visible light, and they wanted to do one in the infrared and approached NASA about teaming on it. Well, NASA formed a team of scientists to meet with the Dutch and see if there was a meeting of the minds about what might be undertaken. And so I was part of a team that was sent over to the Netherlands to meet with the Dutch team. And there was a very distinct difference in the concept for how to do that survey mission. The Dutch had the idea they would build some kind of wonderful, powerful computer that would gather the data from the sky and immediately send to the ground a catalog of the sources that they saw. The Americans thought that was entirely foolish, that you had to bring down the actual data right down to the noise level and do the careful analysis of what sources might exist using ground-based analysis. In the end, the American idea prevailed, and that was a wonderful thing that it did. And IRAS produced wonderful catalogs and wonderful surprises about the sky, even at the depth of a relatively small telescope. So that's the kind of conflicts that constantly have to be ironed out and agreed upon.
Right. So your collaborations, and I have I have a wonderful friend in France, Arnaud, who works in space like you do, and astrophysicist that he is, and he talks to me about collaborating with the Chinese, with the Russians. I mean, it doesn't get any scarier, if you will, at the geopolitical level. And I'm wondering to what extent those will interfere with, I mean, obviously the Russians, it has interfered specifically now, but in general, over the course of your career, how much did that conversation about geopolitics enter into your collaborations, if any, with other powers like China, India, Russia?
I did have interaction with Russian scientists. At one time, the Russians were eager to collaborate, and their government wasn't funding such activity. And the scientists that were interested visited Goddard Space Flight Center, where I was working. And basically, they were desperate for jobs. So we did what we could to give them a comfortable visit to the States and encourage them to continue to try to get involved. But those things are very difficult when we weren't diplomats, we were just scientists. And as far as the Chinese and the Indians, I've had no involvement with those communities. And whether, I mean, certainly the Chinese have had successful space programs. So, impressively landing spacecraft on the far side of the moon, for example. I'm less familiar with what can be done in India, but I believe they probably are technologically fairly advanced as well.
Hey, small business leaders, are you looking for an easier way to onboard and manage remote employees? Or are you feeling you're just doing it all at your company? JustWorks makes it easier for you to start, run, and grow a business. So let me tell you how JustWorks can help your business. Give you an example. For anyone who follows my work, you'll know how deeply I believe that great people are at the heart of every business. And JustWorks can help you attract and retain top talent in a competitive market because their platform gives you access to rich benefits, usually only available to large corporations, plus a range of health, fitness, and financial perks, because you and your team deserve them too. And on top of that, the way people are working is changing, and you need human resources tools that can keep up. Whether your team is local, remote, or distributed, JustWorks helps you comply with state payroll tax requirements, keep up with their state labor laws, and access health insurance plans in any state. They also provide proactive support for federal, state, and local employment-related compliance needs. JustWorks makes it simple to hire and manage remote employees across all 50 states of the United States. It's a cloud-based platform that enables managers and employees alike to quickly and securely access benefits, payroll, and other HR functionality from anywhere, anytime. They provide an intuitive, self-service user experience that makes admin easier for the whole team. And they provide help when you need it with 24/7 expert support for you and your employees. By the way, JustWorks believes it's your right as a customer to have a phenomenal service experience every time. Also provides access to certified HR consultants who can provide tailored guidance and best practices around managing your people, with transparent pricing with no hidden costs, so you always know exactly what you're paying for. You can run your business, therefore, with confidence with JustWorks. So take a look at JustWorks' transparent pricing by visiting justworks.com/pricing. That's justworks.com/pricing for details. So I've had a cosmonaut, a trained cosmonaut on my show, actually, Esther Dyson. I don't know if you've ever come across her name, but she trained, speaks fluent Russian. She's an American who...
Yes. Is she a relative of Freeman Dyson?
No. Oh, yes, that's the mathematician, right?
Yes.
Yes, exactly.
Yes. I knew him. A brilliant man.
So, and she is brilliant too, by the way. And I was just thinking about how you collaborate when you're talking about the Dutch, for example. They had their thesis, if you will. You had your thesis. Obviously, money comes into play in terms of the decision making. But how is there any sort of key to resolving those types of, in this case, I would say, material differences in terms of the way you wanted to put this together? How do you come up with the solution? Because you both want to do the same thing, I'm imagining, but you have different ways. And is it just an argument of proving that my solution is better than yours? How do you come to a solution, really?
That's a very interesting question. I think, in human terms, that tends to sometimes come down to who's the most aggressive. Mm-hmm. And we had some very aggressive members of our US team, based on many years of actual experience in doing the kinds of instrumentation that we wanted to do on that early satellite, for example, talking about with the Dutch. And so they prevailed in the discussions, with one slight exception. The Dutch had a very eminent senior astronomer who wanted to have a special data channel included in the focal plane instrumentation of the telescope. And so a spot in the focal plane was allocated to him. Thankfully, I don't remember his name and wouldn't want to embarrass him if I did. So we had what we call the hole. In addition to the survey instruments, we had a hole in the focal plane for the data for his desired.
His need. Well, so there basically what you're saying, as I hear it, Mike, is that personalities come into play in the way things get resolved.
Very definitely. Space endeavor is a human endeavor. And there's a lot of human emotion involved, human pride, as well as national interests that often must be recognized. The Dutch interest in an infrared mission at that early time was because their government wanted to develop their space technology capability, and that was a fact of life. So human activities ultimately come down to humans.
To what extent do you believe, Mike, that the work in space, it being still somewhat far out, can be a peaceful initiative where it can bring these warring nations on Earth together? Is it still feasible, or have we gone into another zone in your mind, according to what's happening these days?
Well, I think it's very much still feasible. It's still going on. The James Webb Space Telescope is an international collaborative program involving both the European Space Agency and NASA. And it physically will continue to function indefinitely. But the question is, will there be some perceived need to turn it off? I don't know. I hope not.
When you look out into or the future of space exploration, what are the things that excite you the most about what's possible? And the next question is, what frightens you the most in terms of what the future of space exploration could be?
At the present time, there are very definite recommendations as to what comes next in several areas. One is the exploration of planets around other stars. We now know that almost every star has planets. Some have detectable planetary systems, multiple planets around a star. So there's a great deal of curiosity about how do such things form, what's the nature of them, what is the chance that we are alone, that we're the only planetary system in which conditions were such that life could develop. That's a major challenging question. In addition to which, astronomy has expanded in the tools that are available to collect data from the sky. It no longer is just various forms of electromagnetic radiation, light. We also receive energetic particles from various galactic systems or extragalactic systems. We have major progress in seeing early events in the history of the universe, because contrary to Einstein's expectations, his general relativity theory predicted the existence of gravitational radiation. He thought it was going to be too weak to detect, but 21st century astronomers have figured out how to detect it, and in fact have made a direct measurement of the merging of two massive black holes from the centers of galaxies that were merging and forming a new black hole. And the detailed calculations from relativity theory perfectly predicted the nature of the radiation that was received. So gravitational radiation is a new form of observing the universe that we now have. Ultra high energy neutrinos, which are products of high energy collisions of particles can now also be observed, even though neutrinos have such limited interaction with matter that a single neutrino can pass right through the Earth without interacting with anything. But massive bursts of neutrinos of high energy can be detected with massive detectors in the ocean, actually. And so there are lots of new tools available for reading the cosmos. And there's also very substantial attention going to the sociological aspects of research, of diversity of opportunity, diversity of participation, sharing of the resources available to pursue research in astronomy and astrophysics. So there are many aspects presently that are innovations and
discoveries.
Yes.
To use an expression that is debatable. So there are lots of interesting things that are out there. When I, as a layman, observe the news around space, typical of the news, perhaps, they seem to present things in a less good light, so to speak. For example, the number of satellites and the different times that anti-satellite warfare, I suppose, has been going on, where Russians or Chinese or Americans are shooting down satellites, sometimes in proximity to the space station. So the whole idea, this network of maybe tens of thousands of satellites that are up there, seems rather scary for me to think that we rely so much on these things for our daily existence now. But I feel maybe that's just too terrestrial for you almost. But do you have anything that you think is frightening about what's out there, whether it's an asteroid that's going to hurtle towards us, or the sun's going to burn us up? What goes around in Mike Hauser's mind as you listen to this?
Well, we know enough about stellar evolution that it's going to be some billions of years before the sun seriously threatens us to burn up. As far as fleets of man-made satellites, they are broadcasting at radio wavelengths to the ground, and of course emitting infrared radiation because they're at a finite temperature. And they certainly constitute a foreground of confusing noise, if you like. So we have to take account of that, and it may set limits to just how sensitively we can observe at certain conditions.
So let me keeping on the idea of the future and exploration. Then this question, my friend Arnaud and his scientific director David Elbaz, I wanted to ask you specifically, which is, when you think about future discoveries, or to answer the big questions of the universe, such as when did the Big Bang go and all that, do you think that we will succeed more through theory or by observation?
I'm a firm believer that we need both. We need theory, but the theory has to be validated by critical observation that can tell us whether or not the theory predictions are in fact substantiated, in which case we have more confidence in the theory. And if predictions of a theory are violated by observations, then we know that theory isn't right. And that's sort of the way we make progress in science. And so it takes a combination of the two. Being an observer, I certainly believe that that's a critical part of the advancement. So there's one threat from outer space I neglected to mention: impacts of space objects on the Earth, asteroids or comets that survive passage through the atmosphere and collide with the Earth. There have been such. A major one occurred in Russia in recent historic times and obliterated a large area surrounding the impact site. NASA has a program to try to minimize the amount of that threat by sending satellites to collide with objects perceived as being in orbits that could collide with the Earth and deflect them. And they had a successful test recently to impact an asteroid on a potential collision orbit. They collided with it and observed the result of the collision, in fact, with the Webb telescope. So they could see the nature of the debris from the collision, which tells them more about the nature of the object itself. Was it a solid object? Was it a bunch of pebbles collected together? And did succeed in modifying the orbit of that object. So we can, I presume, look forward to missions doing that sort of thing to help mitigate the magnitude of that possible threat to us.
So it's an example of the theory being proved out by an observable action where you send the satellite, it hits it, it moves enough, and so based on the mass of the object and the speed with which it hit, next time, depending on the size of the object, we kind of have a good idea as to what it's going to take to move it sufficiently out of the orbit to not hit us.
Right.
So,
good summary.
Thank you. So, about the future projects, I don't know to what extent you're privy to all the future projects, but do you feel that they are ambitious enough to answer the big questions of space?
The simple answer is yes. There is a process by which the scientific community projects their desires, expresses them to the government in the US and elsewhere. It's called the Decadal Survey of Infrared Astronomy and Astrophysics. It occurs on 10-year timescales, sponsored by the agencies that fund astronomical research, the National Science Foundation, NASA, Air Force Office of Scientific Research, and the Department of Energy, Office of High Energy Physics. All of them fund some aspect of astrophysical research. So they initiate this request to the National Academy of Sciences and to the what's called Associated Universities for Research in Astronomy, an organization formed back in the 50s, or maybe even earlier, which initially consisted of 7 universities actively engaged in astronomy research. Now there are 46 domestic institutions called AURA, Associated Universities for Research in Astronomy. And so on these 10-year cycles, they institute a major review of the current state of the field, of the pressing problems that look like could be profitably pursued at the present time with the current capabilities. And so in 2020, they had such a survey. It was the most recent one. And there are very ambitious lists of things that the community suggested during that survey. So I would say it will be wonderful if they can all be carried out. The survey includes estimates of what they think it will cost to do them, and are quite detailed in the nature of the projects, actual technologies and facilities that are desirable in order to do that. So I'm impressed with the work of those studies. The top level committee is really all members of the National Academy of Sciences, so they're very capable people. And there are sub-panels on all kinds of specific discipline topics that contribute to it. So I would say there's reason for optimism that much of this is going to happen within the next decade. Some of it goes beyond the decade timescale.
In listening to you, I didn't hear many international participants. Are these groups also including associations and collaborations with other agencies from other countries, or is this specifically the US way?
This organization that I mentioned, the Associated Universities for Research in Astronomy, includes 46 domestic institutions and 4 international associates. So yes, it does involve the rest of the world. And those are mostly from Europe, of course.
Like France, maybe. Germany.
France, England, Germany.
Yeah. So when we go for these new ambitious projects, I have to imagine, just back of the envelope, that the more ambitious, the more expensive the projects. To what extent are budgets being allocated to space? Do you feel like this is an increasing allocation, or it's getting tighter and decreasing?
That is always a tough question. At the present time, we're in kind of tight fiscal times in the US and in other countries. And it requires an act of Congress to allocate public resources to do these things. Those who made the recommendations made estimates of what it would cost at a level that they thought might conceivably be made available. But every year it brings a new budget conflict, so it remains to be seen. I'm not a politician, and I can't easily judge the reaction on Capitol Hill.
Well, inevitably, in a national political environment, whichever party's in position, the other will take the opposite opinion, and then when they are in power, maybe it'll be a complete reversal. Because I don't think, and I can't imagine that space by itself is political; it's far more philosophical. But then, when you started looking internationally, there do become national interests in the way we go about space. And there's a little bit of the cock, the guy who says, well, I was there first. I did this first. There's the ego and national pride associated with it. Then there are the amount of work that goes into that has corollary benefits to industry, as we've seen with NASA over and over again. So I suppose at the end of the day, it has to be somewhat political, because at the end of the day, someone has to pay for it. Someone has to be responsible. And then someone wants to be tagged with the Nobel Prize to say, well, I did it, kind of thing.
It's my understanding, and I may be misinformed, that at the present time, I mean, usually these collaborative missions are done between NASA and the European Space Agency, at least. That at the present time, the European Space Agency has not allocated resources for future space missions, which would be a considerable problem in trying to do something large. So I don't know, how long it'll take the various parts of the world to deal with the pressing economic issues that are more urgent than supporting space research, but there's going to be limitations on the short term.
And what about private initiatives? Elon Musk, SpaceX, Bezos with Space Blue, Virgin Galactica. What's your opinion of all that, and how useful will that be in the Earth's mission of discovering space?
I'm more familiar with their successes in technology and being able to launch and recover satellites. I don't know how much research is being accomplished by those missions. Now, they have put astronauts on the moon and brought them back, or at least to the vicinity of the moon and brought them back. And there's some information gained by doing that, especially about the capabilities of humans to handle space flight and both launch and landing. But I do not know of major scientific breakthroughs as a result of those programs.
Those breakthroughs and the larger ambitious spatial projects probably have to be university and government-sponsored agencies. Is that correct?
Yes. Universities tend to get their money from the government. They are not independent, typically fund sources. There are some universities who fund their own observatories, like Mount Palomar telescope is funded by a Carnegie institution, or has at least historically been, which is private money. But there's limited amount of that, what private money can do.
So with your work, Mike, in the cosmic background radiation, are we any closer to discovering the exact date, or how about the Big Bang? I mean, this is like the sort of, for anybody who looks at space, we always want to think about the Big Bang. Do you think we're getting closer to it? Will we ever get that date? How important is it to have that exact date?
I don't believe it's important to have an exact date. It is important to know that the universe is expanding, has been expanding from an initial very hot, dense state by processes, some of which we still don't understand the physics of. We don't know the physics or whatever went on prior to the start of the Big Bang, or that caused it to initiate. So there's plenty of physics to be worked out. As far as the actual date, we know with some accuracy that the observable universe is 13.8 billion light years in size. And we can account for the way the universe has evolved to the state that we see with physics that we know, with the physics of quantum mechanics, with the physics of general relativity, and I think that's remarkable. We can explain how we have the content of the cosmos that we can see, starting from this early state that we can't go beyond yet.
And in your mind, is there even a possibility that there's some other bigger absorbing entity, universe, that's in which the Big Bang happened, and we 13.8 billion light years have been expanding? But is that possible that exists in some other bigger, huger thing, or is that something that theoretically is not viable?
There has been talk about the idea of a multiverse.
Yeah.
There have been a succession of Big Bangs in different parts of the universe, producing much the same situation that we do see visibly to us. I don't know to what, I don't know how much credence to give to those ideas. What would it look like if there were?
It's pretty imponderable.
Pretty imponderable. I think it is a sufficient scientific triumph that we can say what's happened since our Big Bang, that it happened. There's remnant radiation from it that we've discovered, the cosmic microwave background radiation, that confirms that it happened, and that the details of what came after that, just look them up in the physics books.
So look, just last question for you, Mike. Looking back at your career, everything you've done, the people you've met, astronauts you've talked to, and the things you've been privy to see at your level, what kind of advice would you give to people listening and thinking about the future of our Earth planet? What would you like to tell them that would be the wisdom of your career coming in after so many glorious, interesting experiences and encounters?
I strongly encourage future generations to continue the push to understand the cosmos in which we live, to understand the planet on which we live, to understand the solar system in which we live, and to understand the physics governing all of these systems from the microscopic level of quantum mechanics to the macro level of general relativity. All of these things are a part of the fabric that we live in and enrich us whenever we have insights that deal with any of these aspects. So from my point of view, it's a fantastically exciting life to pursue and become part of and encourage the pursuit of that knowledge. And so have at it. I'll be a happy observer for hopefully some time yet, but
indeed. But when you've done all this work, I'm having to imagine it puts perspective on the travails, the minutiae travails of going to the grocery and getting milk and the things that we do in a prosaic manner in our day, when you have this other vision of what's out there.
You're suggesting there's a large disconnect between the practical and the bigger picture. And I certainly...
Well, I certainly feel, I don't know if it's a disconnect, but I certainly feel it helps put perspective on some of the things that we live in and we get worried about.
Well, I certainly agree with that. But there is joy in having the bigger perspective and pleasure in having that perspective that I have certainly enjoyed, and I encourage many future generations to continue to seek that kind of perspective.
Mike Hauser, many thanks for taking some time out to give us your experiences, your perspective on all this. As I have you on my show, I do this with purpose because I enjoy the idea of providing people with a new perspective, because it's very easy in today's world to get sucked up into the bad news, the day-to-day gruel, and add a little bit of air, space in between the mind, and to help us all enjoy our lives a little bit more. Thank you very much, Mike.
My pleasure. It's been a joy to talk with you, Minter.
Thanks for having listened to this episode of the Minter Dialogue podcast. If you like the show and would like to support me, please consider a donation on patreon.com/MinterDial. You can also subscribe on your favorite podcast service. And as ever, rating and reviews are the real currency for podcasts. You'll find the show notes with over 2,000 and more blog posts on minterdial.com. Check out my documentary film and 4 books, including my last one, You Lead, How Being Yourself Makes You a Better Leader. And to finish, here's a song I wrote with Stephanie Singer, A Convinced Man.
I like the feel of a stranger tucked around me, precipitating the danger. To feel free, trust is the reason. Still I won't toe the line. I sit here passively, hope for your respect, anticipating the thrill of your intellect. Maybe I tell myself there's no use in me lying. I'm a convinced man, building an urge. I'm a convinced man, to live and die submerged. A convinced man, in the arms of a woman. I'm a convinced man, challenge my fate. I'm a convinced man, competition's innate. A convinced man, in the arms of a woman. Despise revenges and struggle with deceit. Live for the challenge so life's not incomplete. What's wrong with challenge? I know soon we all die. I like like the feel of a stranger tucked around me, precipitating the danger to feel free. Trust in my reason and let me show you why. I'm a convinced man practicing my lines. I'm a convinced man here in these confines. A convinced man in the arms of a woman. I'm a convinced man, put to the test. I'm a convinced man. I'm ready for an arrest. I'm a convinced man in the arms of a woman.
The world's best-known investor and Wall Street expert Warren Buffett once said, "Wall Street is the only place that people ride to in a Rolls-Royce to get advice from those who take the subway." Mr. Buffett's quote is remarkably accurate, but how many people would rather receive advice from him than someone simply guessing? Welcome to Buy, Hold, Sell, your single source for Wall Street knowledge and profitable guidance. Please join me, Todd Schoenberger, and fellow trader Tobin Smith, as well as host Veronica Dudo, for a podcast known to move the needle for investors. Tobin and I are seasoned Wall Street executives with deep investment experience, and we are prepared to share our advice to those who choose to listen. Download Buy, Hold, Sell today on the Evergreen Podcast Network or your favorite podcast channel.